E is not cell and F over R. Delta G is minus Kc is 2.1, 10 power 91. So reaction is spontaneous. It goes to the completion. Where to refer? Refer to the E cell. E cell is positive, it's spontaneous. Okay. Right. So now it's your turn to find out the Kc. Try to find out Kc for the reaction that has standard cell potential of positive 2.55 volt and transfer 4 electrons. So N is equal to 4 here. So find Kc. For the solution, this one, ln Kc is equal to this one. And F, okay, and F, what is the formula? E and F, E is 1.28, N is 4, F is that, over RT, R, T value, got the ln K is equal to 199.4, Kc is antilog, okay, or epsilon, so you got this one, 1.9, okay, 3.9, 10 power of 86, so Kc value is too big, it's okay, it's normal. 0.5 molar copper sulfate, H2 electrode. So we have H2 electrode at gas pressure. So we know this one has to be P hydrogen. Okay, so either product of the reactant mesti ada yang begini. Should we have this of 1 atm deep into H solution unknown. Value of this one is recorded in the E cell. So this is the E cell value. What is pH? Okay. So, first thing first, we have few steps to follow. First thing first, write the balanced redox equation and determine the E naught cell. So, you know that hydrogen and copper react together, produce hydrogen and copper. Alright, so you find which one is oxidation, which one is reduction. And in the end, it gives you the E cell of copper and cell of hydrogen. So, you got this one. So, this is your value 0.34. Step number 2, determine the form of Nernst equation for the reaction. N is equal to 2. So we use this formula. E cell is equal to E naught cell minus RT over N F ln product over reactant. The product is hydrogen. Okay. And then this is copper. This is P hydrogen. Okay. Over reactant. So reactant. And tadi, just now we have P hydrogen, this one. Always refer to the gas. Okay, that will become your P hydrogen. Okay, it happens to be this gas is seated at the reactant. So that's why P hydrogen is seated above, below here. Okay, right. Okay. How do we know it's equal to 11.68? This one. What I want you to do is this one. This one you bring it here. Okay, you bring it here, make it, this is as the left, this is the part as the right. Okay, this one, this is left and right just now. Okay, you bring the ln as a topic here. You bring the ln as a topic here. Alright, and then that is equal to what we solved, 11.68. Take antilog. Okay, antilog of hydrogen over this one. Okay, that's equal to antilog here, and that is equal to that. So then proceed. Solve the H, that will give you this one, H plus power of 2 over this one is equal to 8.44 10 minus 6. H2 itself is equal to 8.44 10 minus 6. This is minus, times by 0.05. And then H itself is square root of this one. So you got this value. So pH is equal to minus log H. Okay, you remember pH is equal to minus log H. This one in acid base. Okay, so minus log H, concentration H just now, minus log this concentration is equal to 3.19. So I want you to try do it this back. Okay, you have my recording video, so you have to do it back. Okay, refer it back all over again. If you stuck anywhere, just stop the video and try to do it by yourself. Okay, so I hope you are okay with Nernst equation. If you're not okay, you always can do a revision back to back. Alright, so now that remember that Nernst equation, we can find three things in Nernst equation. Number one, from Nernst equation we can get the concentration Okay, from Nernst equation also we can get the Kc, and also from the Nernst equation we can find the pH or pOH. Okay, those three things is coming from Nernst equation. Okay, so I hope you clear. Okay, now we're going to proceed with electrolytic cell or electrolysis. This is nearly third over fourth of the lesson. Okay, this is process is non-spontaneous, as we learned just now all about volcanic cell. There are all spontaneous, so electrolysis is all non-spontaneous. Use electric energy to force non-spontaneous reaction to occur. Anode is where still the oxidation happen. Cathode is still where the reduction happen. Type of reduction occur when you recharge the battery, or substance that undergoing electrolysis must be molten or in solution form, so ion can move freely and conduct. Okay, this is electrolysis. Alright, so we have anode, we have cathode, okay, we have the electrolytes, okay, we have the electrolytic cell. So what we have here, we change it into this one. Alright, instead of voltmeter. So electrode connected to positive terminal battery is normally called anode. Electrode connected to the negative terminal battery we usually call cathode. Okay, so in here, anode is where oxidation happens, similar, and cathode is where reduction happens. Reduction is gaining, anode is lost. Okay, it's similar. Overall, it's still similar. Okay, so electrode that normally used are inert electrodes such as platinum or graphite. Okay, this is the reference electrode. Electrode in electrolytic cell must be molten salt or electrolytes. Electrolyte should be molten salt, any aqueous solution. Okay, so this one, molten means that it have been heated at high temperature. For example, molten NaCl. Molten NaCl cell, it has around 801 degrees. That's why battery, our car batteries normally it can prolong. It can sustain in very high temperature. For example, it's being used for a long road journey. It doesn't have any problem because in terms of molten, where it can resist high temperature. Okay. Alright, so inert electrode placed in a molten liquid and connected to the source of electricity. Okay, alright, so this is a show you. Right, so what are the minor factors that affecting electrolysis? Number one, same position of ion in electrochemical series. Okay, for this one, instead of we looking on SRP like the voltaic cell, but now we looking on electrochemical series. So this is the electrochemical series. You need to hafal sikit. Contoh, for example, kalau nak kahwin meriah, okay, you have to create something that you can remember all the positive series and the negative series. Okay, so the higher it is, become more electropositive. The down it is, it become more. So now this one, electrolysis. For example, we have electrolysis of molten NaCl. We also have of NaCl solution, and also have copper sulfate solution. Okay, there are two types of electrodes. Okay, and also concentration of electrodes. These are the factor that affecting the electricity. Where is the position? What is the type of electrode? Is it electrode of molten? Is it semiconductor, or is it solid? Alright, and then concentration of the electrolyte, is it diluted? Is it concentrated? So which one will contribute more towards electrolysis process? Okay, so this is electrolysis of molten NaCl. You can see of this one. This one nothing to worry about. Okay. Okay. Read this one. As same goes to electrolysis of copper sulfate. Okay. Same concept. So I want to emphasize this one. Two type of electrode. We have inert electrode, and also we have active electrode. So in inert electrode, normally electrode does not take part in the reaction, and also such as carbon, graphite, okay, platinum. Okay, while active electrode adalah metal that do involve in the reaction if the solution is made of the same element. For example, copper sulfate using copper electrode. Okay. Okay. So this is a bit summary of the, again, summary of the voltaic and electrolytic. What made them different? What do you think that made them different? Reduction or oxidation still occur at the same part, okay, but what made the difference is the electron flow. Okay, for example, for voltaic cell, electron flow from anode to cathode, okay, anode to cathode. But for electrolytic cell, electron flow from anode, which is positive now, to cathode, okay, to cathode, which is negative. Okay, so this is those things that make them different. The rest are similar. Okay, comparison. Yeah. Okay, alright. So for type of cell, voltaic cell, for example, if your E cell is positive, okay, more than 0, okay, the sign is minus. Okay, but if your, look at this one, more than 0, more than 0. Okay, for cathode, alright, for cathode, this is process of reduction. The sign is positive. Okay, look at this one, reduction, still again negative. The change to negative, oxidation is positive. Okay, this is the sign, how does the sign